Hello, good afternoon. Myself Deepak Kumar Singh, and I'm going to tell you about computer-aided sensory evolution. Under my topic, I have covered a definition of sensory evolution. I have covered human sense. I've covered human senses with computer senses. I've covered a definition of computer-aided sensory evolution, given the information about eTongue, covered its components, its working. I've also covered eNose, its parts, and its working. Plus, I have covered texture profile analysis, its parameters, and at last I have covered application of computer-aided sensory evolution. Now moving first towards definition. Sensory evolution has been defined as a scientific discipline used to evoke, measure, analyze, and interpret reaction to those properties of foods and material as they are perceived by senses of sight, smell, taste, touch, and hearing. What is the objective of sensory evolution? To study the sensory evolution of dairy products for use of research, provide useful and timely information and recommendation about the sensory evolution of the dairy products, to develop methods and procedures relating to sensory and analytical information for use in research, quality control, and quality assurance, to find out most cost-effective and efficient method to obtain sensory information. What are human senses? As we all know, we have five human senses that are sight, hearing, taste, touch, and smell. In this slide, I have covered comparison between human senses versus computer senses. As we have human senses, we have sight, we have developed color detector in the parallel for computer aided sensory evolution. As we have hearing, we have developed sound detector. As we have taste, we have developed e-tongue. As we have smell, we have developed e-tongue. And for touch, we have gesture instrument. Now, what are computer-aided sensory evolution? These are specially designed hardware and software for the purpose of sensory evolution of food products and beverages. Nowadays, we have e-tongue, e-nose, texture profile analyzers. So, what is e-tongue? The electric tongue can be defined as a analytical instrument that contains an array of chemical sensors capable of characteristic complex liquid sample. The name of the electronic tongue was given for its similarity to the taste sense of humans. Other chemical sensors would generally detect a target chemical substance specifically, yet the test receptor that are on our tongue do not recognize individually every chemical substance. The test sensors used on the test work in the similar way to those on our tongue. They both are non-specific, low selective, which is also called global selectivity. Taste and smells are very linked to the person's perception and interpretation capacity to translate the information received. In this context, taste sensors and electric tongue can be the route to go for a non-biased and quantified evolution of taste. So, what are the components of e-tongue? An electronic tongue is an instrument which comprises of electrochemical cells, that is this sensory array that senses the various chemicals, and an appropriate recognition system which recognizes the detected sample with the reference probes. Working of e-tongue. First, we will look how our tongue works. When we eat a beverage or food, it triggers those sensory organs located on the tongue. Each of them is composed of 5 to 50 to 100 cells and a receptor for a wide variety range of chemical substances. If activated by one of those chemicals, it enables the perception of associated taste. To this end, the taste information is then converted into electric potential and that is transmitted to taste nerves present in our brain. In the similar way, the test sensors which are used in e-tongue were conceived taking nature as a source of information. Indeed, the working principle of a test sensor and the electronic tongue follow the same path of processing the information. When we present a sample to the sensor, their non-specific, semi-selective properties allow them to generate an overview of its gustatory traits. Now, what are e-nose? The electronic nose is a device that detects the smell more effectively than human sense of smell. The electric nose content consists of a mechanism for chemical detection. The electronic nose is an intelligent sensing device that uses an array of gas sensors, which are overlapping selectivity along with the pattern recognition component. The smells are consist of molecules which has specific size and shape. Each of these molecules have corresponding size and shape receptor. In the human nose, when a specific receptor receives a molecules, it sends signal to the brain and brain identifies a smell associated with the particular molecule. The electronic nose works in a similar manner of human. The electronic nose uses sensor as a receptor. When a specific sensor perceives the molecule, it transmits the signal to program for processing rather than to the brain. Finally, we perceive what is the smell of the product. Now, what are the parts and how the e-nose is working? The e-nose consists of three major parts: detecting system, that is this, computing system, and finally delivering system. First, the sample is given into the reaction chamber. There are sensor arrays which senses the gases, which then is amplified by the signal amplifier and conditioning. Then the data acquisition device acquired the data, and data is then processed and is compared with the pattern recognition algorithm. The next computer-aided sensory evolution device is texture profile analyzer. Texture profile analysis is a popular double compression test for determining the textural properties of food. It is occasionally used in other industries such as pharmaceuticals, gels, and personal care. During a TPA test, samples are compressed twice using a texture analyzer to provide insights into how samples behave when chewed. As we can see in this figure, that we have two compressing unit which compresses and provide us the feel of the similar way that our mouth will provide. The TPA test was often called the two-bite test because the texture analysis mimics the mouth's biting action. Now, what are the texture profile analysis parameters? TPA parameters, which we define as a measure of how well a product fights to regain its original shape and size. First one is hardness. Force that occurs during the first compression. The hardness need not occur at the point of deepest compression, although it typically does for the most products. Cohesiveness, how well the product withstand a second deformation relative to resistance under the first deformation. Fracturability. Not all products fracture, but when they do fracture, the fracturability points occur where the plot has its first significant peak, where the force falls off during the first compression of the product. Springiness. How well a product physically springs back after it has been deformed during the first compression has been allowed to wait for the target wait time between strokes. The spring back is a measure at downstroke of the second compression. The next is gumminess. Gumminess is used for semi-solid products. Gumminess applies only to semi-solid product and is the product of hardness and cohesiveness. The next is chewiness. This is used for solid products. Chewiness applies only to solid products and is calculated as gumminess and springiness product. Now, what are the application of sensory evolution using computer devices? These are used for analyzing flavor aging in beverages, quantify test masking efficiency of formulation, analyze medicine stabilities in terms of taste, monitor environmental parameters, benchmark target product, and quantify bitterness or spicy level of beverages. Now, moving toward the conclusion, using humans is still an acceptable option and is often the way to go. Yet, there are situations when human experts panels cannot or should not be used. Here are a few examples. Repetitive quality control on an industrial processing line with a high volume of samples and where precise and consistent results are wanted. And also, when the samples could be potentially toxic, such as testing of drugs, pharmaceuticals, evaluate food spoilage, and alcoholic drinks, we should not use human for doing sensory evolution. And unappealing and unappetizing samples such as dogs and cats could not be evaluated through human senses. We should use computer-aided sensory evaluation for the evaluation of such type of foods. And also the economic reasons and financial expenses that occur for the time of recruitment, training, and running tests and supervising the sessions. And if we want a globally understandable best representation of our product, we need to bring informality in our sensory evolution. Whereas computerized sensory evolution reduces the time for evolution and reduces biasness arising out of human sensory evolution methods and bring uniformity in the result produced. These are some of the references from where I have taken my sources and has prepared this PPT. Thank you for listening patiently.